Let us see another example. We are still on jointed rods. Okay, uniform rods AB, you hear the word uniform, it means that the weight is going to occur in the middle of that rod or those two rods of equal length. So the length is equal, but they're not telling us the actual length. As smoothly jointed together at B with masses 6 kilograms and 8 kilograms respectively. The end, so we start by drawing that. So we have AB and BC, but they are joined at B, meaning B is their common point. So this is going to be AB. So if this is A, then this one is going to, if this is AB, then we have also BC. Those are the two rods of together at B. So they are joined at B with masses 6 kilograms. So because they are uniform, we are going to say their weight is going to be in the middle. So this is the weight of AB, which is 6 kilograms. So to get the weight, to get the mass times B. Also this one is in the middle. This is my midpoint. The weight here is still the mass, which is 8 times B. That is the first part. And now because I don't know the length, I say let the length of the rods be 2L. Because they say they have equal length, I know that because they are uniform rods, this weight is going to divide this into 2. So this one is going to be L, and this one is going to be L. And because they are having the same length, this one is also going to divide this into 2, and that also into 2, because they are equal according to the question. Okay, then we continue. The NC is freely in at a rough horizontal surface. This NC is in at a rough horizontal surface. What does it mean? It means that now we are going to have, because this one is hinged at a horizontal surface, we are going to expect a reaction at C. And then this one is going to be is also conduct here, and L is on the same surface with the coefficient mu. You're also going to expect a reaction at A. Reaction at A, as you see, basically. But because these two are rough, it means we are going to expect some friction at A, which I'm going to call mu R A. That's how we get friction. We get the coefficient of friction times A. Because it's the same surface, even this side, we are going to be having friction, and this one is going to be at B, which will be mu R A. This is C, mu R C. Because the surface is the same, it means that the coefficient of friction is going to be the same. Then we continue. The points A, B, and C are in the same vertical plane, as you can see. An angle BSC, so meaning they are giving us this angle at 30 degrees. But remember, if these two are equal, so in simple terms they are going to form an isosceles triangle. So if this and this are equal, it means that even the base angles are equal. In simple terms, even this one is 30 degrees. If A is at the point of sleeping, find the reactions at A and C. Basically, we first start with that. So, you want us to get reaction at A and C. It means that now we said if you don't get these reactions, you take either moments at A, then you also take moments at B, basically. So, now, if I'm to take moments at A, it means that I will get the reaction at C. If I'm to take moments at C, I will get the reaction at A. Oh, I told you, take moments at A, resolve up vertically upwards, and then you'll be having the two equations for these two reactions. Then after getting one, you can get the other. I'm going to show you that in this method. Let me get. Okay, so now, here we are now going to take moments. Now, this is what we call the equilibrium before separation, or immediate before separation. Before separation, that's when we get the moments. Okay, now, you see that this one is going to be, if I divide this into two equal parts like that. I think you see, to get now, I'm going to take moments at A. Take moments at A so that I can get the reaction at C. Or, we can first resolve vertically upwards, like this. Then see if I resolve vertically upwards, I have RA, then plus RC equaling to, this one's acting downwards, we have 8 6g plus 8g. It is going to give us 14g. And I call this equation 1. So now, we either take moments here or we take moments there. So here, be careful. I'm now going to take moments at A so that I can get this one anti-clockwise. Now, there you see, now we need the distance from here up here. How am I going to get the distance? Now, I know the whole when I add this and this, I get 2L. So from here, there is 2L from A to B. And also from this to this, there is 2L. If I'm to do that from there up to there, even here, there is 2L. Okay, so how am I going to get now? Remember, I want to get this distance from here up here. It means that this distance from here up to here is going to be the same distance from here up to here. So I start by getting this. Okay. So now, if we consider this triangle AB, let me call this one N. If we consider AB N, I think you can see it clearly here. A, B, N. Now we start AB is 2L, and this is 30 degrees. Now, I want the distance from here up to here. So my AN, because I have this and this is adjacent, it's going to be 2L, then cos 30 degrees. As simple as that. So, meaning, if I want now to take moments at A, it means that now my RC, then times. Remember that AN is the same as this. So, it means that from here up to here, up to there, because this is an isosceles triangle. It means that now I'm going to get this distance twice. I'm going to multiply this distance 2 times. So I'm going to be having now 2 times 2L cos 30 degrees. That is the distance from here up to here. Because you know that from here up to here is this, and it's the same from there up there. And note that N is equal to NC, implying that now SC is going to be twice AN. That's the idea we are using here. Okay, so that's the only anti-clockwise force you see from A. Then this one is going to be anti-clockwise, clockwise, and this one is going to be clockwise. So the question is, how do we get this distance from here? We start with this one, so I have 6E. Then times, I think you see, from here up to here is just L. So I want this from here up to here from A. This one is going to be L cos 30 degrees. This one is going to be L cos 30 degrees. Then plus. Now I want this force 8B. 8B now times the perpendicular distance. Now, right, I'm not going to specify. From here, I'm going to add AN from here up to here. Then plus from A to this. But now, you see this one, this distance here is going to be L, then cos 30 degrees. But this one, because this one has to divide this into it to encompass. So this one is going to be also L cos 30 degrees. And also this one will be the same as this L cos 30 degrees based on this angle. So basically, if I want to get now, that's why this one decided E is going to be just this. Now, if I want to get for 8B, I add this, I add this, I add this. I think we said we're going to be adding 3L cos 30 degrees. As simple as that. So, let us simplify and see. We see that what is common, we see that L is common. So L is going to disappear because it's common without. So here I'm going to be having RC times 4 equaling 2. Now this is going to be 6B times root 3 over 2. This one cos. Then plus this 3 times this, I'm going to get 24B times root 3 over 2. And from there, I can set our RC. You can heavily get the answer there. Okay, let us simplify. Sorry, here we have 2 times 2, then, okay, we made a simple error here. We forgot the cos. So this is going to be times 4, then cos is root 3 over 2 equaling that. So let us simplify. I think it's this C by the constant is also common. So you now see here that course is also going to go. So you see that this is common throughout. This one is common, this is common, this is common. So we have now this is going to give us 30. So which will give us here you think we can see we are going to be having 4 RC equal to 30 gig. And from there, our RC is going to be 15 gig over 2 newtons. That is our RC. So from here, we can come and get our RA. From 1, that our RA is going to be 14 gig minus RC, which is going to be 14 gig minus 15 over 2 gig, and start from there. Our RA is going to be, this is 28 minus 15, that's going to give us the 13 over 2 gig newton. So that's the reaction at A and C. So the other example I used when you're taking reaction, but when you come to this, it's better you resolve vertical upwards, then you take moments at one point, and then you get the other. So horizontal and vertical components of the joint at B. Now, the joint at B, we consider the idea of after separation. After separation, that's the idea I'm going to consider. So, it means that we are going to separate this and this. But we say we consider only one. So, considering this one, you see, separate this. We say that the reaction here is going to be acting vertically downwards, and that side. So, after separation, I'm going to be having a case like this. So that is my reaction. So this is going to be the X component. It's going to be the Y component. So I'll be having this case. Now here is where I had my reaction at A. And here I had my reaction. I had my mu RA, which was equal to the friction force at A. So I also had the weights. This weight was 6 G. So we consider one. You can also consider the other, but we basically consider only one. So there, what we are going to do, we resolve. So this is our A here. So what we do, we resolve vertically, and then we also resolve horizontally, and then we get our cases there. So resolving now, you see vertically, when I resolve vertically, I have this, and this. So resolving vertically upwards, I have RA plus, RA only is going to be equal to, this one is acting downwards, 6B plus Y. So it's that my Y is going to be RA minus 6D. So this Y is going to be my RA, which is 13 over 2D minus 6D. And when multiply there, you can have this one going to get 12 minus 13, which will give me D over 2. And these are going to be our newtons. Okay, after getting that, I think, what is my test? Okay, now, so remember here, we are going now to, after getting now our Y, means that now the remaining part, we are going to take now moments at A. But now here, I want you to see this A. This is simply our B here. So if I think we can remember this triangle here. If I redraw it here, let me try to draw that triangle here, which is having only these two forces here. If you remember this triangle, A, B here, now we have our reaction here at A. Remember, this is now going to be our frictional force in that direction, mu R A. Then we are adding forces here. We have X, and here we have our Y. Remember, this is our 30 degrees. This is going to be our weight acting here, which is 6 G. Now, remember, this was RL, and this was RL, but the wall was 2L from up there up to down here. Now here we are going to take moments at A. So, taking moments at A, you have to be careful. I don't know if that space will be enough for me. Okay, let me take moments at A. So, taking moments at A, remember I want to get now the x component. So, taking moments at A, anti-clockwise. Here, be extra careful. So, take moments at A, now is that I'll be having, take moments at A, is now I'll be having this first going anti-clockwise, this one clockwise, all these ones running, and then this one is also clockwise. So, it means that now my x then times the perpendicular distance from A to this. Remember, this is 30 and this is 2L. It means that now this is going to be 2L, this is opposite, sine 30 degrees. So this is the distance from here up to here. Or we can also illustrate here. And this distance is going to be that. So now the perpendicular distance from here up to here is the same as from here up to here. So this one now, I'm going to say now the x, take moments at A. This will be the first times the perpendicular distance from here up to here, which is from here up to here, which is 2L sine 30 degrees. That's the only force acting anti-clockwise. Equaling to the sum of moments acting clockwise, we have, you see here, this one is going to act in this direction, I think you see. But say from here up to here, from here up to here towards L. So I'm going to be having now 6b times R from here up to here is L cos 30 degrees. Easy, because this is the noun hypotenuse. So it's going to be L cos 30 degrees, then plus. The other force acting is this one, the y. So y times, now you see the moments at y acting in this direction, the perpendicular distance from here up to here is the distance. We add this plus this, which is going to be 2L cos 30 degrees. For this one is L cos 30. Basically, that's what we have there. So then we put in we know what this is, so this one is going to be capital X, then times 2L times sine 30 is a half, equaling to 6b times L times root 3 over 2 plus our y, we know what our y is, b over 2 times 2L times root 3 over 2. There we can easily simplify. I think it's that L is common throughout. I cancel that L. I think it's that you can also multiply through. Okay, these 2 cancels with this. And then you multiply through by 2 here, by 2 here, by 2 here. So see that the only thing surviving here, we have 2 factor x equaling 2. This is going to be 6b root 3, then plus, here one is surviving, here we have b root 3. And so that this one is going to give us our x, which is going to give us, when we add 6, and this will get 7, yeah, 7b root 3. So that now our x is going to be 7b over 2 root 3, and these are going to be meters. So from there, so after getting that, now we have x. This was our part B. Now allow me to divide this here so that I can write our part C. So this one is going to be my part C. So my part C, now we're going to get mu. You did that. So here we just resolve now horizontally like this. To resolve horizontally so that we have, going in this direction, we have mu RA equaling to x. So we have R mu times our RA, which is 13 over 2b equaling to x, which is 7b over 2 root 3. I think it's that our b is going to go, this is going to go. So meaning that my mu is going to be 7 over 3 root 3, I mean over 13 root 3, and that's going to be our mean. So that's how we handle that question with the ease. I think you have seen. So always you separate one. After separating, you consider one. Then you consider premium, and so on. This one we are considering premium. But because this is in premium, upward forces are equal to downward forces. Horizontal forces are equal to also the horizontal forces. Going inside, we have only this equal to this simple as that. So that's it, members. Now this E, you can remove this E by putting 9.8. Then you get the answer there. You can get the answer there. The same, you also get the answer there. So that's it. I wish you well.